Guys, this is 7.4 day 2. We're going to continue working with different properties of logs. And so we're going to start moving towards solving with some exponential log equations. And so we're going to use the properties as they relate to one another. So the biggest thing to know is that a log base b and an exponential base b, those are inverses. So they essentially cancel each other out. The reason here is log base b of b is 1, so we're left with 1x. Same thing if I go the other way. If I have an exponential of base b raised to something with log base b, those are inverses and will cancel. B raised to log base b again is 1, so I'm left with 1x. So if I have things raised to the same exponent, those are equal to each other. And then these, if I have the same log base, are equal to each other. Okay, so we're going to use some of those properties here. Okay, so right now, if I wanted to evaluate this, I have log base 3 of 3. Those are inverses, so I'm left with just 11. Okay, so I want to kind of create something like this if I can. So if I'm looking for, okay, 81, can I rewrite that using a base of 3? I can. 3 to the 4th is 81, so I could rewrite that as log base 3 of 3 to the 4th, and then I have something just like over here. Log base 3 of 3 is 1, so we're left with 1 times 4, which is just 4. Okay, here we have the opposite. So this is an exponential of 5 raised to log base 5 inverses, and then we're left with just 10. Okay, here again we have 2 raised to log base 2. We're left with just the argument there, which is 8x. Okay, something to know, and I'm going to show you guys. Yeah, I'll do this in a second. These particular problems would be something that would show up on a no calculator portion of a quiz or test. But this is good to know also for calculator too. So I'm going to show you a couple things. So basically it's saying if I have a base, so our most common bases on the calculator, we have our common log and natural log, okay? And we're going to get to natural log here a little bit later. But we can choose one of those bases if I don't have a given base. So like I might not have log base 4 on my calculator. Now I am going to show you guys, a lot of you do, so I'll show that here in a second, but I'm going to show how to do this without a calculator here first. Okay, so basically what we want to do to evaluate these is we want to pick a new base. So A is a new and different base. We want to pick A so that it relates to both x and b. So whatever x and b are, those two are original base and the argument, we want our new base to relate to both those. So here's what I mean. I want something that I can raise to a power to get 4 and 8. So that's going to be 2, right? 2 squared is 4, 2 to the 3rd is 8. So I'm going to pick my new base to be 2 because it goes into both of those exponentially. So we're going to rewrite it just like this using log base 2. So we have log base 2 of 8 over log base 2 of 4. So we just said, okay, 2 to the 3rd is 8. So 3 is what log base 2 of 8 equals. 2 squared is 4. So that is what x equals. Okay, we're going to do something very similar on this one. Pick a value that goes into both of these exponentially. So you might think 4, but remember 4 doesn't go into 8 as an exponent. Okay, I want to pick something that goes into 8 exponentially, which again in this one is going to be 2. 2 third is 8, 2 to the 4th is 16. So we're going to do the same thing. So we got log base 2 of 16 over log base 2 of 8. 2 to the 4th is 16, 2 to the 3rd is 8. So 4 thirds is evaluating that one. Okay, 9 and 27, value that relates both of those exponentially would be 3. So we have log base 3 of 27 over log base 3 of 9. 3 to the 3rd is 27. 3 squared is 9. So that's how we evaluate that without a calculator. I am going to show you guys on here that you can actually, a lot of you, if you have this option, this is a nice way to check. And if you have a calculator on an assignment, test, quiz, whatever, then obviously you can use this. Like I said, these problems, because they work out nicely and there's a base that relates well to both of those, these would be the kind that would show up on a non-calculator portion. But just so you are aware, A lot of you have this option if you have a newer calculator. If you go to math and you scroll down, there is often this option, log base, and you can enter exactly what you want. So if I wanted log base 4 of 8, I can enter 4 and then use my arrow to get over to the next entry point and then hit 8. And again, my fraction will give me a decimal. I can go back into math and hit fraction, and it'll turn that to a fraction as well. So that is an option too. And if there's not a nice number that I can use as a new base where these worked out pretty nice, this would be a great option too. If you don't have that option, that's okay. We're going to show you something later where you can use common log and natural log instead. Okay, we've got one more example here. Okay, the Richter scale is actually a logarithmic scale. The Richter scale is used to measure the magnitude of an earthquake. So M here stands for magnitude. And then it corresponds to E is just the energy released in ergs. Okay, so that's just what E is. So it's the energy. Okay, so magnitude and energy. So magnitude is like the actual reading we would see on a Richter scale. So when they say it was an 8 on the Richter scale, that's the magnitude. Okay, so the tsunami that devastated parts of Asia in December 2004 was spawned by an earthquake that had a magnitude of 9.3. How many times as much energy did this earthquake release compared to the 6.9 magnitude earthquake that struck in San Francisco in 1989? Okay, so basically, I want to find the energy of the Asia earthquake and the energy of the San Francisco. And when it says how many times as many, we're dividing, right, to answer that question. So I want to find E. So I'm going to write, this one is for the earthquake in Asia, okay? So it had a magnitude of 9.3, so I'm going to put that in for M, and then I'm going to write the rest of the equation out here. We don't know E. That's what we'd like to find. 10 raised to the 11.8. Okay, and we're going to do the same thing for San Francisco. Okay, so we've got, that one was 6.9, and the rest is the same. So we're searching for these two different energies. Okay, so we are going to solve for E. Okay, so here's what this looks like. We want to isolate the log expression first. So I'm going to get rid of this 2/3 by multiplying by the reciprocal, 3 halves. Okay, so I get 13.95 equals log of E over 10 to the 11.8. Okay, and now to undo, let's actually do that first. Okay, so I'm going to actually split this, you guys, using my log properties. Remember, division I can split into subtraction. So we're going to do 13.95 equals log of E minus log of 10 to the 11.8. Okay, so remember, this is log base 10, right, when there's no subscript. So log base 10 and exponential of base 10 cancel. So we're left with 13.95 equals log of E minus 11.8. So now we're trying to get E by itself, so I'm going to add the 11.8 over. Okay, so we've got 25.75 equals log of E. Okay, so now the last thing I need to do to get E by itself is to get rid of this log. So remember, this is log base 10, so its inverse would be an exponential of base 10. So I'm raising both sides. So this is the base, these are now the exponents, okay? So we now have 10 to the 25.75 is E. Okay, so this is the energy release for that earthquake in Asia. We're going to do the same thing for San Fran. So I'm going to start with that same step. I'm going to multiply by 3 halves, get rid of that fraction. So I'm left with 10.35 equals log of E, or 10 raised to the 11.8. We're going to do the same thing. We're going to split that. So we got split into subtraction, and we get the same exact thing we had on the other side. The log base 10 and exponential of base 10 cancel, and then I can add 11.8 to both sides. And we get 22.15 equals log of E. And again, to get rid of that log, we're going to apply an exponential of base 10. So exponential base 10 and log base 10 are inverses. So we've got 10 to the 22.15 is the energy release for the earthquake in San Francisco. So they asked how many times more energy did the Asia earthquake release than the San Francisco earthquake? So to answer that question, we're going to divide them. So we've got 10 to the 25.75 divided by 10, 22.15. I'm writing it like this too, you guys, leaving it as an exponent because I can use my exponent rules and subtract, right? So then I'm just left with 10 to the 3.6. Now when I enter that in my calculator, so we've got 10 raised to the 3.6. Okay, so I'm going to approximate that. So we've got approximately 3,981 times more energy. All right. Okay, that's the last example for this video. Thanks for watching.